Welcome to the Wind Sustainability Series. This is episode number 2, Preliminary Cockpit Preparation and Exterior Walkaround. In this video, I will share with you the good practices that can be applied to achieve more efficient operations both on ground and during the flight. First, I will speak about the preliminary cockpit preparation, and then I will focus on the exterior walkaround. So let's now begin with the first phase, the preliminary cockpit preparation. As you know, during this phase, the flight crew ensures that all required safety checks are completed and that the aircraft is correctly set up. From this moment, the aircraft requires to be electrically and pneumatically supplied. For that reason, the Airbus SOPs require that the APU is started during the preliminary cockpit preparation. However, when ground electrical and pneumatic units are available, the APU is not necessary yet, and its start can be delayed. But why is this positive in terms of efficiency improvement? To answer this question, we can look at this table that displays the extra fuel consumption due to the APU use on ground, when both the APU generator and the packs are on. If we take the A320 as an example, we can see that by using the electrical and pneumatic ground units, we can save approximately 130 kilograms of fuel and 410 kilograms of the associated CO2 emissions per hour. These are significant savings that demonstrate that optimizing the APU start time during ground operations and relying on the ground units as long as possible are good techniques to increase fuel savings. But what happens when there is no ground supply available and the APU start cannot be delayed? Even in those cases, some fuel savings and reduction of CO2 emissions are still possible. Sometimes, and depending on external conditions, you may consider switching off one pack during ground operations. In terms of fresh air, the requirements are still achieved even if the cabin is full of passengers. However, keep in mind the importance of passenger comfort as well. In extreme conditions, with high temperature or humidity, having one pack off may not be recommended. Other times, if the boarding time and external temperature conditions allow it, you may even consider switching off both packs. The avionics ventilation is still ensured by the fans, but remember taking into account the necessary time to recover a comfortable cabin temperature before the passenger boarding starts. For example, on an A320, it takes about 30 minutes to cool down the cabin from 38 to 27 degrees Celsius, with both packs on, doors closed, and no passengers on board. Okay, so now we know that we can keep one or both packs off sometimes. But what does this mean in terms of efficiency improvement? In this table, we can compare the APU consumption depending on the pack's configuration. For instance, even if the APU is running, for an A320, turning off one pack allows saving approximately 20 kilograms of fuel per hour, and turning off both of them approximately 30 kilograms. But you may be asking, are these recommendations still valid during transit? In terms of fuel optimization and CO2 reduction, the answer is yes, especially for long transits, but also for most of the short flights. You should just remember that the increased number of starts may have an impact in the life cycle of the APU when defining the rule to apply. Before moving to the next phase, I just want to remind you of the importance, in terms of fuel efficiency, of the computation of the preliminary takeoff performance. You will get more information regarding the optimization of the performance parameters in episode number 5, dedicated to the climb phase. Let's now continue with the exterior walkaround. As you know, This phase involves an external inspection to ensure that the general condition of the aircraft is satisfactory and safe for the flight. This includes checking any missing parts or panels, as well as the position of the main aircraft and flight control surfaces. Therefore, we can take advantage of the exterior walk-around to monitor the normal degradation of the aircraft's external surface. Remember, to minimize the aerodynamic drag and optimize the aerodynamic efficiency, the airframe must be as free from irregularities as possible. For that reason, the flight crew should take special attention to the areas of the aircraft that the air hits first. For example, they must check that the fuselage panels and the flight control surfaces are correctly aligned, that there are no worn seals on the airframe, that the paint is in good condition without peeling, and finally that the aircraft is clean, because dirt on the aircraft also degrades its aerodynamics. After the inspection, do not forget to inform the maintenance personnel of the findings so that corrective actions can be taken at the first opportunity. Performing these actions as soon as possible keeps the aircraft's operational efficiency, which can result in significant reductions in fuel consumption. So, to sum up the recommendations for these two phases, remember that during the preliminary cockpit preparation, the EP2 and the air conditioning configuration can be optimized depending on the situation. By delaying the EP2 start when the ground units are available, or by keeping one or both backs off with the EP2 running. Also, keep in mind that we can use the exterior walk-around to monitor any degradation of the aircraft's external surface. This helps to maintain the aircraft's operational efficiency. That's all for today. Thank you for watching this episode of the Wind Sustainability series. Stay tuned for more on how to reduce fuel consumption and CO2 emissions during the other phases of the flight.